Hi, I'm going to quickly do this because I have about 10 minutes right now, but I want to give you some guidance so that I help you out. I think the issue looking at these questions and through your eyes is that it might be difficult to know what is being asked. So the first thing is that you have these equations. This is your parametric curve, and this is a another, it's an actual value, and they want to find the value of t. So you really want to solve three equations. Possibly just one will do it, but let's see. So let's just take the first. I'm not going to use the letter T. I'm going to use the letter U because I have a feeling that I'm going to need the letter T later on. So let's just do that. The command is solve U times cosine of U minus 50 is equal to, and you put two equal signs, minus 50 minus pi. Let's see what happens. And I want it to solve for you. So it tells me I can't solve it, so I'm going to put these little double dash n, and it doesn't like it. So let's try one of the second equations. Try u times the second one. Double equals, and I have 90 minus 90 plus 10 times pi. And it gave me a value. It gave me u equals, it looks like pi. So, and I obviously can see that from just looking at the equations. Then I would just test whether putting pi in there will make the value turn out the way it's supposed to. So let's try that. Oh, I can see already. Just put in pi here and you'll get exactly the value of negative 50 minus pi. So it looks like this works. All right. So now that you know t is pi, okay, I kind of see what's going on here. Now that you know the value of t, what this question is really asking for is, it's asking for capital T of 1. So let me see. So we found t at 1 on the WebAssign. They want you to find t at pi here. So that's what's wanted. And they want you also to do the derivatives on Mathematica. What we found yesterday is that it might not be clear how to do this. And if you go and Google search, not plot it, I think this was the site that we found. See how it has x is equal to r cosine t, y is equal to r sine t? That's how you're going to actually have to enter it in. Let's see if we have more code. So really what they want you to do is this x of t is equal to, I forgot already what it was, minus t times cosine t minus 50. So you put t times, and this is why I used u earlier, because I didn't want to have it pollute. So now I have x of t, and then I go up and look, see it says t derivative. Let's just check what that is going to do. Oh, look, it found the derivative for me. So that's really what you want to do. You can probably just click on it and get the derivatives. And that will give you the derivative, and you might have to do some pencil and paper work in between. So you find the derivative of the r of t, and then you normalize it by dividing by the magnitude after you plug in the value of pi, and you'll be plugging in the value of pi. Now, some of you did this on Mathematica, putting in pi in for t, like you might have set t equal to pi. If you did that, you'll need to go to evaluation and quit the kernel. It's kind of like a restart. It keeps your sheet the way it was, but then it allows you to restart and clears the value of t. So you should do that so that you're not you're able to do these contour plots and all this stuff later. On C, okay, they want the equation of the plane that passes through this and is orthogonal to C at that point. Well, if it's orthogonal to C at that point, you have the normal vector. And then they want you to plot both the plane, they want you to plot that plane, basically. And they want you to use this contour plot 3D. And the last one is they want you to find the arc length. There's a formula for arc length. It's exactly what it sounds like. It's the actual length of the arc. The Google search you should do is arc length of a parametric curve. And you'll see tutorial math here, PDF. It's a formula. And there you go. So if the x is given by f of t, the y is given by g of t, and you can continue on the z is given by h of t, then they keep going down. There's going to be, the arc length formula is this guy right here. They should have a more condensed formula. There it is. So here you will have, with dy dt squared, you'll have a dz dt squared as well. And you'll have to go from alpha to beta. I did a problem like this on WebAssign. You'll have to figure out what the limits of integration are. My guess, because you have, it's going to be a closed curve and you're going to have the full period is probably 0 to 2 pi. My guess is that the alpha will be 0 and the beta will be 2 pi. I haven't had time to go through that in detail, but that's what my educated guess is. And then finally, I think that's all you need. And it tells you how to use it tells you the command. But if you don't want to use the commands or figure out how to use these commands, just Google search, how do I integrate on Mathematica? And it will give you a formula. So you can take those derivatives by hand, square them by hand, put them into the thing, and tell it to integrate for you. Hope this gives you a short update. I'll do a longer one a little bit later, but I wanted to have something uploaded so that you can get started on number 4.